Hey everybody, my name is Uncle Bernie, and it just so happens I'm here with Keith Marshall. He is a Master Certified RV Technician and an RVTI Certified Trainer. So Keith, what are we looking at today?
Well, today I want to show you how to connect batteries in your RV. We're going to talk about differences between 6-volt batteries and 12-volt batteries, and different ways to connect multiple batteries in your camper.
That sounds fascinating. Can't wait to get at it. Stick around. So what are we going to be looking at first here, Keith?
Well, these are wet cell deep cycle batteries, and they're still the most common type of RV battery in the campgrounds today. We're seeing a huge increase in sales of the lithium and other more sophisticated types of batteries in the industry. But for average families who use their campers on weekend getaways, these systems come with a huge price tag and special maintenance requirements. So for today, I'm going to discuss just these ordinary deep cycle batteries that we see on most travel trailers, fifth wheels, and motorhomes. I also want to talk about the need to have a battery in the first place. Since most campgrounds today give you access to 120 volt AC power, what do we even need a battery for? There's two very important reasons. The first is called AC ripple. When we plug in our power cord to a 120 volt AC power source, we're energizing the onboard converter in the camper. And the converter is designed to produce enough DC current to run all the lights and still able to charge your battery. If the battery is not connected in the RV system, all the lights will still work, but we have that AC sine wave that bleeds through to the DC side of the system.
All right.
Now, AC sine wave is dangerous to various control modules like this. This is a control module from a furnace, very similar to the one in a water heater as well. These control modules are designed to accept good, clean DC current from the battery. And if AC ripple is present, it could damage these control modules over extended use. So when a good battery is connected in the system, that sine wave is filtered out. So it makes it safe to use with all the DC control modules in the RV appliances. The second reason is what we call reserve amp capacity, sometimes referred to as RC or RA. As said, when the power cord is connected to 120 volt AC, the converter is energized and produces enough electrical current to keep the lights on inside the coach and still charge the batteries. But a heavier load like a slide out motor or a jack motor or even a 12 volt heating element requires more current to operate than the converter can produce at any given time. Think of a battery as a gas tank in a vehicle. The converter is like a little imaginary gas pump that follows you around, is always connected to your gas tank. It keeps just enough fuel flowing into the tank to keep it topped off while you're driving under normal conditions. But occasionally you need a little more gas than that imaginary gas pump can provide. An example is then when we speed up around a slow moving truck or when we're pulling a trailer up a hill. So we rely on the fuel that's already in the gas tank that gives us that extra power we need to get around that big truck. The battery is the only device in the camper that stores reserve electrical power for when we need it. Just like a gas tank, we rely on that reserve power or amp hour capacity when we need a little more than what the converter can provide all by itself. Now, batteries are rated by the amount of reserve amp hour capacity they can store, or RA capacity, sometimes called RC. It can also be listed as CCA. A typical Group 24 deep cycle battery, for instance, has 100 reserve amp hour capacity, while the Group 27 battery, which is a little larger, has 160 reserve amp hour capacity. And in comparison, the 6-volt batteries have a much larger plates in each cell, which translates to even higher storage capacity of about 225 reserve amp capacity. So many customers install an extra battery or sets of batteries to store more available electrical current for when they need it. And to increase that storage even more, they may opt to install sets of 6-volt batteries in place of 1 or 2 standard 12-volt batteries.
So Keith, what if I wanted to have that extra power, extra battery? You're going to show us how to hook something like that up?
Yeah, to connect two 12-volt batteries in your coach, first we're going to disconnect any load from the camper. I don't want to have any sparks at the terminals. That can damage the battery terminals, and it can be slightly dangerous. So we'll shut off the battery disconnect, which I've already done,
Right.
and unplug the power cord to disable the converter. Now, the DC system in our RV requires a nominal 12-volt power supply. Nominal means it's within an optimal range of 12 volts, but not exactly 12 volts. And I'll show you what one battery has here. One battery is going to show about 12.6 volts.
Wow, within a hundredth point there, yeah.
Right. What that means is this battery is fully charged. I got it right off the shelf. Now, to see the actual voltage, you would use a voltmeter, set it on DC volts. But even if it's not exactly 12 volts, that's okay, because we're going to still be in that optimum range if it's close.
Right.
Okay, so we want to utilize the storage capacity of two batteries. They must be of the same rating and the same approximate age.
And why is that?
In other words, an old battery is always going to pull the new battery down to its level instead of the other way around.
Okay.
So we always want to start with either two new batteries or two of similar age. Connect the 12-volt batteries together, and the way that I do this, I've already done this here, but I'm gonna walk everybody through this.
Sure.
First, I've connected the positive terminal to the positive terminal with a jumper wire. And I want to emphasize to everybody that it's real important to make sure those are tight. You don't need to torque them down hard, but they need to be snug enough so that these cables do not move.
Right.
If those cables have any movement, that's resistance. This is the highest current draw in the whole camper. So we don't want to have any resistance or any movement or sparks at all. So I connect the positive to positive and tighten down those terminals. And then I connect the negative to negative
All right.
and tighten down those terminals. Now to connect it to the RV, I'm going to start with the positive cable and land it on the positive of one battery.
I'm just going to show where it's coming from the tongue area and right over to the
Right
battery.
over here to this first post. And we could connect the negative to this post, but the problem with that is the coach will tend to draw this battery down a lot faster than the second battery. So in order to utilize both of them together, I bring the ground wire, the negative, over to this negative post on the second battery. Now, what I can do here is show you that what I've done by connecting these positive to positive and negative to negative, I should have about the same output to the coach as we would with one battery. And you can see it's 12.6 volts.
Perfect. So by running it parallel, retains the same voltage as you would have one battery, but just gives you much more power to draw from.
Exactly. Now, the total voltage of two parallel connected, and that is called a parallel connection here, when we go positive to positive and negative to negative, should be the same as one battery.
So Keith, why would people consider 6-volt batteries?
Well, 6-volt batteries have fewer cells than a 12-volt battery. If you look at the top of these batteries, a 6-volt battery has 3 cells versus those 12-volt batteries that had 6 cells. Well, since these cells are fewer, they have more space to make them bigger, and they have much larger plates in each cell. Now consider each cell as about 2.1 volts when it's fully charged. So if I continue those 3 cells, and I should be able to measure from each battery just about 6.3 volts per battery.
There you go.
There's the first battery, and there is the second battery. 6.3 volts.
Excellent.
Now, if I connect 2 batteries together, end to end, I like to call it, I'm continuing these cells from this battery all the way to this battery. What I've done is I've made a connection with a jumper here. It's connected the positive of this battery to the negative of this battery. So virtually what I've done is I've created one big 12-volt battery out of two 6-volt batteries. Now when I measure the voltage from end to end, I should have about the same as we measured on the 12-volt batteries, about 12.6 volts.
Look at that. Amazing.
And that is where we make the connection to the coach. This is the positive battery cable that goes to the coach, and this is the negative battery cable that goes to the coach.
So Keith, I'm going to throw you a curveball. Now, in some of these big motorhomes, they may have 4 or even 6 of these 6-volt batteries. You know, how would you connect those? These are in series. You can't continue in series, right?
Absolutely.
Yeah, so what would you do?
Consider this as one pair of batteries. What we can do is connect several pairs and multiples of 2 in parallel. In other words, I connected these 2 together, virtually made one battery out of 2. I can connect another set together, making another virtual 12-volt battery,
right,
and then connect the positive of that set to the positive of this set, and the negative of this set to the negative of this set. What I've done now is created what's called a series parallel connection. I connected 2 6-volt batteries as one pair, another pair of 6-volt batteries, and those 2 pairs I've connected in parallel. And that gives us even more storage capacity. So the only thing that limits the number of batteries we can connect together is the space and weight restrictions of the camper itself. Now, I want to mention, if you want to research some of the more elaborate, more expensive, and sophisticated lithium, solar, and inverter systems, please talk to one of our reps at the dealership. These systems can be very confusing and they are very expensive. So if you are interested in expanding to that type of system, be sure to do your homework. Ask lots of questions. These large systems can be very confusing to understand, but a good vendor will be able to cut through all the confusion and get you set up with something that'll fit your RVing lifestyle. Now, as the RVer's trusted resource, as always, our goal is to make sure that you have a great camping experience.